Last video we looked at the central limit theorem and what the central limit theorem was and what it resulted with. What we're going to be looking at this video is a couple of examples that show us the central limit theorem in action. So let's go back and just recall that, remembering that the sample mean is exactly the same as your population mean, and that your sample deviation is now equal to the deviation of the population divided by the number of the sample square rooted. Now that we have this information included in our data set, we now need to start looking at the notation of the questions. And you'll notice in part 1 and 2 that there is two different parts of notation. Excuse me. So what you will notice in part A is you'll see that we have a population of X and then we have a sample means of X. So looking at part A, we're going to have to use a different mean and standard deviation to what we will use in part C. So let's have a look at calculating part A, going back through how we did it with normal CDF with our calculator. So if we look at our calculator up here on the right hand side, we've got the normal distribution curve up there already, or function up there already. So let's go to our lower. So our lower is 65. Our upper is 75. Our deviation is 10. And our mean was 70. Now remember, when you're working with these here, you're trying to think in the back of your head, does the answer I get make sense of what we're working with? We're not going to go through that here today, but always remember that that's data that you want to have in the back of your head, because you're always going to get an answer no matter what. Now I know that this here is correct, okay, because I can recall what's going on in my head with the normal distribution, and this makes sense of what it looks like. So we've answered part A. Part B is now asking us, well, let's calculate the mean and standard deviation of the distributions of the sample means of X. Well, we know that the sample mean of a population of 20 is going to be exactly the same as your population. So we've got 20 here. However, the deviation of that sample mean, is going to be 10 over the square root of 20. Which then, if we do that in our calculator, I think we get approximately 2. So we get about 2 as your standard deviation. So for part B now, we're going to do exactly the same method that we've done in terms of your calculation, but this time we're going to be looking at in terms of a mean and standard deviation. So let's exit here. Let's go back into your calculator. Okay, so let's now put in there, these are exactly the same. Your deviation now is 2, and your mean is still 70. So if we click on this here, we now get, when we look at the calculations, an answer of about 0.988, which is a lot more fuller within the data set itself, because remember, your standard deviation now is only 2. If you're not convinced by this, we could go back into our calculator. Let's go into menu. Let's scroll all the way down to distribution, and we could sketch these distributions in the normal graphics here. So, for instance, we want it to be between. So let's now click the top one. Your lower, let's just do it on the calculator here. So your lower is 65, your upper was 75. There we go. So 65, 75, deviation was 10, and this here was 70. If we execute, we can see our graph looks like it should be. If we then exit this, and then come back and then change some of this data set around, so now this time this is going to be 2, we can now see that our graph is a lot more fuller because the deviations are much closer to your mean. So this does make sense of what we've got. So when we're doing our calculations, it's really important that we're using the correct notation to match up with what we're doing in our calculator. So let's have a look at this second example. So if we scroll down here, we've got a second example here where we've got Dale. Now, Dale has an MP3 player and he uses AAA batteries. We are certain that AAA batteries is being used varies according to the mean of 10.85 and the standard deviation of 1.35. AAA batteries are sold in packs containing a different number of batteries. Suppose Dale buys a pack of batteries and this pack is donated by X bar N. So if we scroll down to our next page, let's have a look at this information here. What we're going to look at here is we're looking at two different types of distributions. Now this is the type of question where we have to explain which one is correct and the reason why. Now we learned back in the original video about Central Limit Theorem that as n increases, the graph becomes more normal, it becomes closer to your mean, and that means that your deviation has decreased. So in this example here, we have two histograms, one that's representing the x bar of 4 and x bar of 15. However, this question is asking us here to explain which histogram A or B best illustrates the x bar of 4. So, from our understanding of the central limit theorem, as your n increases, your graph should become more normal. So in this case here, our explanation will be this. X bar 4 has to be histogram A. And the reason why is the sample size is less than 15, and then according to the central limit theorem, as n increases, the graph becomes more normal. So what we can see here is a direct demonstration of what happens to the graph when n increases, and an explanation of why x bar 4 must be A, because x bar 15 is a higher sample, so we expect that to be more normal. If we take this a little bit further with this question, let's take it to this next section here. According to the central limit theorem, now as a rule of thumb, something can be considered normal when n is greater than or equal to 30. However, there are going to be exceptions, and those exceptions come with the idea of, well, if in context of the question it's already considered normal, then n is greater than or equal to 30 doesn't have to apply. So in this case here, according to the central limit theorem, the distribution xn will be approximately normal if n is sufficiently large enough. Now, if this didn't have this second part of the question here where it said referring to A, you would definitely say, you know what? No. Because we've been told as a rule of thumb, n has to be greater than or equal to 30. However, in part A, we can definitely see there between A and B that x bar 15 was approximately normal. So therefore, anything that's greater than 15 is going to be even more normal. So therefore, we can state here that, well, n equals 20 will be sufficiently large enough in this case, because we said that 15 already was. So anything greater than that will be larger. And then an example again of finding the approximate value for when we have x bar 20 is greater than 10. Again, it's just another example of using that notation. Again, you know you have to use the mean and deviation that we have to find to get this calculation. So remembering again, your mean of 20, well, that's going to be equal to the population, which was equal to 10.85. Your deviation of 20 is equal to the standard deviation of n. In this case, it's 1.35 over the square root of 20. So we could leave your answers like this, okay? And most times it's good to leave it like this unless I ask you to do significant figures. So let's find out what is the answer going to be for this, going back to our calculator. So let's go back here, and we'll stay in this screen for now because it doesn't really matter. Okay, so we're going to go up here. We're going to change this to match up with the sign that we want. We're going to come down here and say, well, our x value this time is 10. Our deviation is 1.35 divided by the square root of 20. And then your mean is 10.85. And we get an answer of 0.9975. So 0.9975. Again, how do I know this is correct? Well, if we come back and look at the mean was approximately 10.85. Our deviation, if we go back, it's only 0.3. So it's less than 1 inch point. So therefore we know this has to be correct because it takes up most of that graph. An example is Central Limit Theorem. This is important to understand. It's a massive concept when it comes to statistics. Remembering the notation, identifying when am I using the sample mean, when am I using the sample deviation as opposed to the population mean and population deviation. Remembering what happens to your graph once n increases. Alright, I'll see you in the next video.